Picture going out to a bar with your friends in 3 months' time and playing pool. As you line up your shot, you think back to this exact presentation and remember the physics involved in your game of pool, how the billiard balls are a perfect example of an elastic collision. You decide to explain to your friends the phenomena of elastic and inelastic collisions, and it goes a little like this. The definition of an elastic collision is a collision between two objects where no kinetic energy or momentum is lost. The definition of momentum is a measurement of mass in motion, which is mathematically denoted as mass times velocity. For a head-on collision with a stationary object of equal mass, the projectile will come to rest and the target will move off with equal velocity, like a head-on shot with a cue ball on a pool table. An object with a large mass will launch a smaller stationary mass forward with double the velocity after the collision. An object with a small mass launched towards a stationary large mass will bounce off with the same velocity in the direction that it came from. The definition of an inelastic collision is one in which the momentum of the objects before and after the collision differ and are not the same. Additionally, in an inelastic collision, kinetic energy is lost. As you can see in this picture, you have two separate masses with two separate velocities. After they collide, the masses are stuck together and they continue in this forward direction with a different final velocity. A real-world example of an inelastic collision is a dropped ball of clay. Next semester in your pottery class, you drop a ball of clay on the floor. As it falls, it has a mass and velocity which changes when it splatters on the ground. It has lost kinetic energy and momentum. In a perfectly inelastic collision, internal kinetic energy is not conserved because some internal kinetic energy is lost to sound. Take, for example, a car crash. In some serious car crashes, the cars actually crumple and stick together, losing their original mass and shape to pieces that have flown off. This is the mathematical equation that represents an elastic collision. The momentum of the first object plus the momentum of the second object before the collision should equal the momentum of the first and the second object after collision. To summarize, momentum is maintained in elastic collisions, whereas momentum is changed in inelastic collisions. A collision where both objects stick together is called perfectly inelastic. Collisions usually fall on a spectrum favoring one collision or the other, but are rarely perfectly elastic or inelastic. Next time you play pool, think about these concepts and tell all your friends.